Hi everybody, this is Alex with my Module 8 discussion presentation. Just going to start this off. I'm just using the Excel tables that were provided by Professor Barron. So on the first one here, I just dropped in a copy of the sample proportions that I got from the application she provided. For this first one, it's just our confidence interval for P, or the population proportion. We're using the sample, our P hat, basically to estimate what that might be. In my sample, we got you can see over here, proportion was about 0.18, or 18% of the sample were caring for their offspring, and the standard deviation for that was 0.38, or about 38%. From that we can expect kind of a variance in there of about 38%, either one way or the other. Basically from this we can see a large majority of them were not caring for their offspring, and therefore we're about 95% certain that between 8% and 28% of galoots in the population are caring for their offspring. So down here on the number line, I've marked that kind of in this range. Now the estimate was like 50% of them were caring for their offspring, so that would be like way over here, sitting pretty significantly outside of our confidence interval there. That'll come into play a little bit later. I'm going to hop over to the hypothesis test for P just so we can look at that real quick and kind of compare them. Here I just used the significant threshold of 5%. I used a two-tailed test because we weren't told that we were expecting it to be either lower or higher than the 50% that we were looking for, just based on what we were told about the population beforehand. So we're basically again estimating that 50% of the population was caring for their offspring. Proportion and standard deviation are the same here. Running the test, I had the sample size of 40 galoots were obtained, and just crunching the numbers, our test statistic was like a negative 4.05 approximately. So we're going to reject that hypothesis. The population proportion that care for their offspring is likely not close to 50%, based on what we saw, and I'd estimate closer to 18% of the galoots are caring for their offspring based on the sample that I took. So I marked that on the distribution here, basically -4 or +4 standard deviations from the center of this distribution, which would have centered it at 0.5. And if everything went the way that it was predicted to, we'd expect this whole area under the curve here to be colored in. So basically, almost all galoots would be within 3 standard deviations of that 50% caring for their offspring, and what we found was that they were not. So we can pretty much say that that is not the case, and we're expecting the number of them to be either lower or higher than that. And based on the sample I got, we're expecting about 18%, so significantly lower than what was predicted. So you can see the relationship here is notable. So if we look at that confidence interval, we're looking at this range, and we're looking around here with the estimated value coming in, and we've got these guys sitting way outside, so that seems appropriate. I'm going to hop over to the confidence interval for mu of the population. That's the population average weight, and we have X bar, which is our sample weight of this. Again, 40 galoots were sampled, and I got a mean on this one of it's like 12.57 pounds, about 12.6 pounds, and a standard deviation of like 3.83 pounds, about 3.8 pounds or so, sitting off that. So the smallest galoot in the sample was like 5.4 pounds, largest was 19.5 pounds. and the average dilute was like, again, 12.6. So basically we'd expect a majority of the glutes, about 68%, to weigh between 8.74 and 16.4 pounds, and almost all of them, like 99.7%, to weigh between 1.08 and 24.06 pounds. So that's that within 3 standard deviations of our 12.6 pounds. The confidence interval that we calculated here indicates that we're about 95% certain, again I used a 95% confidence interval there, that the average weight of glutes in the population, that's our mu, is going to be somewhere between 11.5 pounds and 13.59 pounds. So we've got that marked down here on the table. Now with the hypothesis test, we were looking at around 10 pounds. You can see that sits well outside about the center of our confidence interval. It sits right about here, so it's way over there. So you can kind of predict what that's going to say for our hypothesis test, but I'll hop over there. Here again, we're using a significance threshold of 5%, and we're going two-tailed again because it wasn't specified that we were looking above or below that predicted value for weight. So our null hypothesis was they were going to weigh an average about 10 pounds, and my sample size again was 40. 12.57 pounds was the sample mean, and 3.83 was the standard deviation of the sample weight. Again, we've got a really well outside of our normal standard deviation that's going to contain most of the population for the test statistic here. And so this p-value is like basically 0. So again, I've got these markings way outside. Again, if the 10 was our actual value, we'd expect pretty much right under this curve here to be shaded in, and again, that's not the case, so we're going to reject this hypothesis. The average weight is likely not 10 pounds in the glute population, and we're going to estimate closer to 12.6 pounds based on this sample. My expectations as far as how I might compare to you, my fellow classmates, with regards to these tests and the samples we've taken. I would expect the standard deviations to be a little bit smaller, and you guys to be a little bit closer to the true population mean if you had a larger sample size. I had the smaller sample size of 40, and I know some people had the 160. So I'd expect it to be a little narrower of a distribution for those of you that had the larger sample size, and it's probably going to hone in closer to our actual population values for both the population proportion and for the population mean, so p and mu there respectively. Hope you guys all enjoyed this assignment, and I hope I covered everything there. Look forward to hearing your feedback, and I will see you guys on the forums. Thanks. Bye.